everyone, and welcome to Chapter 9 on quadratic equations and functions. We're going to be starting off our discussion of quadratic functions by looking at something called the square root property. So let's take a trip down memory lane. We learned that a quadratic equation is an equation whose left-hand side has the form ax squared plus bx plus c. And we learned how to solve these guys reasonably quickly and effectively using factoring. So let's warm up with a little example, baby example. Here we have x squared equals 16. So we're going to do what our training tells us to do. First thing that we want to do is get everything on one side so that we have x squared. All right, so we have x squared minus 16 equals 0, and then we want to factor. And then we use our zero product property. And there we have our answers. X is equal to 4 and x is equal to negative 4. We have two solutions. But for something that's so simple looking, it's kind of a lot of work. So we're going to tackle this guy a little bit of a different way. And that's what we're going to be doing for this first bit of Chapter 9, is developing some other techniques of solving quadratic equations. All right, so let's look at this again. And we want to remember from our discussion on radical functions that when you take the square root of a number squared, you end up with its absolute value left over. So what we can do is, instead of getting everything on one side, then factoring, then applying the zero product property, what we're going to do is take the square root of both sides. So we end up with the absolute value of x is equal to the square root of 16, or the absolute value of x is equal to 4. So what does that tell us? Well, x is any number whose absolute value is 4, and I can think of two numbers that fit that description. Positive 4 and negative 4. So we end up with the same answer, but we've cut down on a lot of the work. So let's summarize what we just did. If we have a number that is greater than or equal to 0, and we know that x squared is equal to k, then the absolute value of x is equal to the square root of k, whatever that is. And furthermore, once we think about what the absolute value means, we really just end up with both of the square roots of k. That is, we end up with the principal square root and the negative square root. So x is equal to whatever this symbol is next to the square root of k, and this just really literally means plus or minus. So that's the square root property. Let's look at some examples. All right, so for some examples, what we're going to do is use the square root property to solve these guys. So first up, we have x squared minus 50 equals 0, and what we want to do is get the squared term by itself on one side. I can do that by adding 50 to both sides. And then I'm going to take the square root of both sides. So we have the absolute value of x is equal to the square root of 50, which means that x is equal to plus or minus the square root of 50. And we want to make sure that everything's completely simplified. So there we have our answers. 5 square root of 2 and negative 5 square root of 2. Slightly more complicated is this next guy. So we have 3y squared minus 108. I'm going to add 108 to both sides. And before I take the square root, I want to isolate as much as I can, so I can divide both sides by 3. There we have y squared is equal to 36, and then I'm going to take the square root of both sides. so that y is equal to plus or minus 6. All right, next up we've got some fractions. Probably not too friendly, so why don't we clear that fraction first by multiplying the entire thing by a common denominator. Luckily there's only one fraction, so I just need to multiply both sides by 3. Subtract 15 from both sides. Divide both sides by 2. And take the square root. Of course, the square root of 1 is 1, so u is just equal to plus or minus 1. All right, let's see here. Next up, we have 5r squared minus 2 equals 34. So just proceed as usual. I want to add 2 to both sides. Then I'm going to divide both sides by 5. Then I'm going to take the square root of both sides. Well, let's see, the square root of 36 is 6, but the square root of 5 is irrational. So I'm just going to keep it like that. And of course, you don't want to forget your plus or minus sign. Okay, moving on up in difficulty here, we have this guy. Now, normally what we would have to do is FOIL this out and then distribute the 4, get the 48 on the other side, and it becomes kind of a lot of work. But we can actually just do this using the square root property. So first I'm going to divide both sides by 4 to get the y minus 7 squared term by itself. Then I'm going to take the square root of both sides. So I'm not quite done yet because I want to get y by itself, so let's add 7 to both sides. And then we want to simplify. So that means my two solutions are 7 plus 2 root 3 and 7 minus 2 root 3. All right, next up, let's see. So actually straight away I can take the square root. So I'll have x minus a third on the left-hand side. Let's see. So square root of 5 does not simplify. Square root of 9, however, simplifies to 3. And of course, plus or minus sign. Then I add 1/3 to both sides. And to make it look a little bit nicer, I'm going to combine everything into one fraction. All right, now here we have something. Well, we would have to use our AC method to factor this guy usually, but this is actually a perfect square because we have something like an a squared and a b squared, and the middle is 2 times a times b. And if you don't believe me, well, the proof is in the pudding, so to speak, I guess. So then we have that b is equal to 5 and a is equal to 4n. 2 times a times b is equal to 2 times 4n times 5, which is 40n. So, super easy to factor, actually. We have 4n plus 5, quantity squared. Then we can take the square root of both sides. Of course, the square root of 4 is 2. Now, I'm not completely done yet because I still have to solve for n, so let's do that real quick. And we end up with plus or minus 2 minus 5 all over 4. Let's actually write out what those numbers are. So we get that n is equal to either negative 3 over 4 or negative 7 over 4. That about wraps it up for that square root property. I mean, it's not really too bad. So certainly not quite as painful as some of the other stuff that we've done. Next up, we're going to look at something a little bit worse. So I just want you to be mentally prepared for that, but we'll get through it.